for giving me a chance to give a presentation on this topic. And I also would like to thank Dr. Varitap to making this happen today. Okay, so my presentation today is about emission-based signal control policy. Is there economic justifications? First of all, let's take a look at this picture. This picture on the left, I took this picture. I took this picture in Chiang Mai a few years ago, and you can see from this picture it's a little bit hazy. This is not due to fog, but it's due to PM2.5, which is very unhealthy. Okay, you can see that from the AQI index, which is 209, which is very high and very bad to the health. And from this picture, you can also see the signal control. Okay, so one of the straightforward way that we think about this situation is, can we somehow relieve the pollution problem by using traffic signal control? Can we do that? If we can do that, it's a very straightforward way to do it. Okay. In my department of highway, we have tens of thousands of intersections, but about 2,200 signal line intersections. So we aim that maybe we can do something with those signal line intersections. But there is a more fundamental question that we have to answer before we do it. Is it really worth economically implementing emission-based signal control? This is, I think, it's more fundamental than doing it, because if you are studying traffic flow theory, especially in traffic signal control, you see many of signal control algorithm. Okay, but I think this is a more fundamental question that we should answer before we proceed. So this is an overview of my presentation. First, I will talk about emission and delay signal control in brief. Okay, then I will talk about intersection fundamental diagram and emission intersection fundamental diagram, which is similar to macroscopic fundamental diagram. And I think MFD is very well known for most of the traffic engineer. And then I will talk about marginal external cost of emission and congestion ratio based on intersection fundamental diagram. And I will use this ratio as a metric to, I will use this ratio as a guiding indicator whether we should minimize delay or whether we should minimize emission. And then I will talk about some observation in Bangkok. And thanks to Bangkok Metropolitan Administration, and I think someone from BMA today, thank you very much for your help. You giving me data so that I can do this research. And then I will talk about absence of economic justification. And then I will summarize my presentation with conclusion and future research. So let's talk about signal control. When we talk about signal control, there are several performance measures that we usually discuss. The first one will be delay. This is the most common one. The second one is stop rate, or the number of stops per time unit. The third one is emission. And the fourth one is fuel consumption rate. Okay, the four major performance measure when we talk about signal control. And we know from the literature that when we try to minimize delay and we try to minimize emission, these two objectives give us two different timing plans. Okay, and you can see from the literature, there are many studies on emission-based signal control algorithm. And I think some of the researchers in this room, maybe in the past, have written some paper regarding emission-based signal control. Okay. But when we talk about congestion and emission, we have to somehow weigh economically between two of them. Which one is more important? So in this study, in my study, I try to answer two questions. The first one is it worth implementing emission-based signal control policy or not? And the second question I try to answer with this research is, in what traffic condition should emission-based signal control be implemented? So these only two questions I try to answer. First of all, let's talk about a little bit about macroscopic fundamental diagram. And I think this work in MFD is very well known to everyone in this traffic flow theory field. And I think if someone get a chance to read this paper by I think by Professor D'Aganzo, in the acknowledgement, the data provided for this study was supplied by Kura Sensei here. Okay, so from the MFD with some certain assumption, we can get the relationship between production and accumulation look very nicely like this. Okay, this is the starting point. Okay, and the MFD concept apply to a network. Okay, so what I do with the signal line intersection is I scale down this concept a little bit into a smaller scale, into one intersections. Okay, so if we have the data such as the total travel distance and the total travel time that pass to the coordinate line that we define over an intersection, we can construct a very simple relationship between flow and density. Okay, we get something similar to the MFD, but smaller scale. Okay. And then in the next step, together with intersection fundamental diagram, I use the emission rate function, which is a function of emission of average speed. Okay, if we assume emission rate function, we can somehow construct emission intersection fundamental diagram. I generate this figure using simulation. Okay, I assume some emission rate function and change the traffic signal, change the demands, and see how it's look. So we got a three-dimensional representation of the emission intersection fundamental diagram. And based on this diagram, we can calculate the marginal effect if we adding one additional vehicles into an intersection. Okay, with this concept, we can calculate the marginal external cost of emissions and also the marginal external cost of congestion. I take the ratio of marginal external cost of emission over marginal external cost of congestion as a guiding indicator. If this ratio is greater than 1, it means that externality of emission is greater than externality of congestion. So if this ratio is greater than 1, we should go forward with emission minimization policy. But if this ratio is less than 1, the externality of emission is less than that of congestion. That means we should go forward with delay minimization optimization. So I do something very simple. Okay. Based on this concept, I get the data from metropolitan administration from 3 intersections, which is very near Chulalongkorn University. I think right now we are sitting somewhere in this location. Yeah, right now. These 3 intersections are very close to these locations. The first intersection that I get the data from is the Lertworawanich intersection, this one. And the second intersection is Pathum 1 intersection. And some people call it MBK intersection, close to MBK. And the last intersection that I get the data from is Ratchaprasong intersection, where I think when you go to Ratchaprasong intersection, you see some people worship Papom, the golden statue, a lot of people there dancing, that kind of thing. This these three intersections are one are the most congested intersection in Bangkok and in the very center of Bangkok. Okay, so I make a certain assumption for the value of time and value of emission damage cost. Okay, and I consider three type of greenhouse gas: carbon monoxide and volatile organic compound, NOx. Okay, and with some value of the damage cost, I got this the value of the damage cost from Pollution Department of Thailand. Okay, maybe it's not relevant to other country, but this is what the most recent value that I obtained from Pollution Control Department. And the value of time is conducted by my Department of Highway. Okay, with the data that we got and with the assumption that I made, okay, I generate intersection fundamental from the data, and then I calculate the ratio, okay, the ratio as a function of accumulation. The blue line is the intersection fundamental diagram, and the orange line is the ratio. Okay. From this figure, the ratio is greater than 1 when the intersection saturation, when the intersection degree of saturation is less than 0.033. Okay. Move to another intersection, but to one intersection. The ratio is greater than 1 when the degree of saturation is less than 0.24, which is quite low. Okay. The last intersection, large Pasung intersections, the ratio of externality of emission over that of congestion is greater than 1 when the degree of saturation is less than 0.21, which is very low too. So what we learn from this simple experiment is, as accumulation increase, the emission externality grow but slowly compared to externality from congestion. It grow faster. Okay, so therefore, at the very low accumulation, this ratio is above 1, and it justifies emission-based control. But at high accumulations, this ratio is very small, much smaller than 1. So from the assumption that I made, this may be a warrant delay-based control. Okay, when accumulation getting higher. So from the finding that I found from this study, at moderate to high accumulation, we found that we don't have economic justification for emission-based signal control when we have high accumulation or when we have high degree of saturations. However, this depends on the value of time and the value of emission damage cost that I put there. However, this finding I think is quite important, because when we try to implement emission-based signal control at very high accumulation, we might reach public dissatisfactions, and also we reduce operational efficiency if we try to do that at very high accumulations. And also the absence of economic justification of emission-based signal control is also, I think it is a valuable insight, because if we try to achieve low emission, we cannot just do it by adjust the traffic signal. We need something more. We need complementary approach. Maybe we can go forward with electric vehicle adoption, or maybe we can go forward with fleet modernizations, or maybe we can implement low emission zone signal control only cannot make that achieve that. Okay. So what we learned here, I try to summarize my presentation a bit. Emission-based signal control is not universally justified, and we also have to consider hierarchy of externality. And maybe we need some complementary strategy if we would like to achieve low emissions. Okay, not just signal control. And signal control policy must be adaptive. Okay, we cannot just have one objective function. Maybe we have to switch. This depends on the traffic conditions. And this is my last slide. For the future research, I plan to integrate this ratio as a part of real-time adaptive signal control system. Maybe we can consider it as a weight factor when we try to implement traffic signal control in the future, maybe. And the next plan that I would like to do is to evaluate EV penetration impact on this ratio. And I think the most important thing that we should think about is we should consider a broader discussion on externality and social goal of traffic management. That's all I have. Thank you.
Yes. Yeah, still have time.
Please.
Yes, please.
Could you
Yeah. Yes.
If you consider the approach, probably the
Yeah. Yes.
therefore
Yeah, and also the intersection block with, yeah. Yeah.
depends on the delay,
Yes.
right? Therefore, this Q and K seems to me is basically a function of the delay.
Yes. You're right. But I add free flow travel time into it.
Okay.
I add free flow travel time into the delay to get the travel time of each vehicle. Yeah.
So this curve actually depends on the delay.
Yes.
I wonder what the difference the pattern.
It's quite similar. It's quite similar, but I add some free flow travel time into it. Yeah. Yeah. And also the volume that we try to yes, it's depend on the delay, but the thing is the flow is also depends on the direction of the vehicle, like directional distribution of the traffic. I see some result from Bangkok Metropolitan Administration Traffic Operation Center. They try to plot volume and delay. And I think for the volume and delay, it's quite difficult to represent the relationship because volume cannot be distinguished by directional distribution of the volume. Thank you.
Thank you very much.
interesting and also very important such work. And I'm very curious about the economic evaluation of emission. In particular, you say the value of emission, VOE, for NOx or VOE for CO, and factor of determining your conclusion.
Yeah.
So do you think how much the value of VOE can affect the conclusion? I mean, and also it is not easy to find the appropriate value of emission. Could you please tell me any idea about the measurement of VOE or how much it affects to your conclusion?
Actually, the first time when I write this paper, I think about this question. If we would like to evaluate the value of emission damage, or we would like to evaluate the value of emission reduction cost, I think these two things are different. So what I'm trying to do is I try to evaluate the value of emission damage, not the reduction cost. However, the best value that I can find is from Department of Pollution Control in Thailand. They give me some value, but this is very much very sensitive to the conclusion that I can make. Actually, I have one. Oh, I have one more slide, but I didn't show it. From my conclusion, I say that we have absence of economic justification. But when this will change, there are some certain situation that this will change. Okay, so my conclusion is very much depend on the cost of time and the cost of emissions. So the change would happen when we value emission damage cost much higher than what I do now. And this can happen when we have air quality crisis. Maybe like, for example, in Chiang Mai, the value that I use in this experiment might not applicable in case of Chiang Mai because there are a lot of people who get sick from air pollution. Okay. And the second one may be equity and externality. If policymaker, they weigh public health and environmental justice much more important than congestion or commuter time, this will change. And also, if we have some new technology, for example, CAV vehicles, maybe it can coordinate with each other and provide a smooth driving situation. And in that case, the balance of my conclusion will shift again. Okay, but with the assumption I make, maybe it's incorrect. Time is worth more than emission right now with the value in the assumption I make.
I'm very interested that, as you say, the low accumulation situation, the emission-based control becomes much more important. So this conclusion is quite interesting. And then if you change the VOE parameter, but this conclusion is still valid, then we are very, how do you say, happy about that. So, but if you change the VOE parameter, and if this conclusion can change, it's a little bit difficult to.
Actually, I write a paper, but it's still under review. I did some sensitivity analysis of the parameter, and actually, it's quite robust. This conclusion, I change about plus and minus 50% of the value of time and the value of emission. I still get the same conclusion. Yeah.
That's very good. Thank you very much.
Please.
Yeah, thank you for your presentation. So I'm very interesting. But I have a question. So I don't understand why the MFB uh, decreased over why the decrease right hand side? Yes.
Why is
Why?
the
Why?
why it has the red?
Yeah, the line decreased. So Q is decreased. Why?
Why? Because in
So
in the yeah
I guess so. Your problem is consider the situation with the Q downstream of the intersection, right?
downstream.
Downstream of the intersection. So in my understanding, so you want to make some signal control using this, right? If so, so usually, so we consider no Q down, no Q on downstream the intersection. Because if there is Q on downstream, so congestion effect is not appear. So signal controls cannot improve the traffic situation.
Yes.
If there is a queue downstream.
You mean
Downstream.
the queue from the downstream link, right? It cannot improve the situation.
Or cannot so reduced. So control effect is reduced because of the queue downstream. Downstream.
From this is the data I got from VMA, and I think in the you can see from this slide, I put the dotted line for the red line, because in simulation it never happened. In simulation it never happened because I simulate one isolate intersection. It never get blocked. The downstream link never get blocked. So I have only the green part. But the data that I got from DMA, sometimes we have the downstream section blocked.
Okay. So your analysis has been done.
Yeah.
So including the situation with the congestion on the downstream, right? Okay.
Yeah.
Yeah, it's very interesting.
Yeah.
Hi, thank you.
I put the dotted line because it's never happened in simulation.